This is a male Anna's hummingbird. It uses its outer tail feather, R5, to produce this sound during its courtship display. Removing R5 eliminates the bird's ability to make the sound, but what's curious is what happens when R4 is removed. It sounds like this, which is weaker than this, which was the same bird, unmanipulated. In this video, I'm going to show that R4 amplifies the dive sound by testing the feathers in a wind tunnel. Air is flowing from left to right. This is R4. When I lower R5 in front of R4, a loud sound is produced. Removing R4 decreases the loudness of the sound, while replacing R4 increases the loudness. So, what produces this effect? This high-speed video shows how R5 produces sound. Its trailing edge flutters in the airflow. This high-speed video shows that, by itself, R4 flutters at a much lower frequency. But, when put together with R5 in front of R4, the motion in R4 is altered. But the motion is complex, making it difficult to use high-speed video to tell exactly what is going on. To quantify the vibrations, we used a scanning laser Doppler vibrometer. This video is a demonstration of a scan. In the sped-up video, the laser can be seen jumping from point to point, using the Doppler shift of reflected light to measure the vibration at each point. As you can hear, the feather is making the same tonal sound. Our control was to put a flat metal plate behind R5, which is shown here. The plate is not touching R5. Also, not shown, we measured R5 by itself and R5 with R4. Once the scan is done, the computer makes an animation of vibration. This is an animation of the fundamental frequency of R5 at a different angle from the videos. Here is an animation of R5 plus the flat plate. As in the previous scan, the trailing edge of R5 flutters at a relatively high amplitude. Note that the flat plate does not move. By contrast, here is an animation of R5 with R4 at the fundamental frequency of the sound they produce. R4 is moving at least as much as R5 at this frequency. So, to conclude, the scans from the scanning laser Doppler vibrometer support the hypothesis suggested from the high-speed video. When R4 is right behind R5, it picks up vibrations from R5, resulting in an increase in the loudness of the sound. This is Chris Clark, demonstrating that feathers can amplify the sounds that other feathers make through sympathetic vibrations.